use logs to solve exponential equations. This is a pretty straightforward idea since exponentials and logs are inverses. If you want to solve something, if you want to undo a square, you use a square root. If you want to undo multiplication, you use division. If you want to undo subtraction, you use addition. And if you want to undo an exponential to get at your variable, you need to use a logarithm because that is the operation that will undo the exponential. But you have to use the correct base. So we're going to take a look at this problem again. Example 1 again, in a slightly different light here. So 4 to the 2x is equal to 1/2. This is base 4. So the inverse operation is log base 4 of x. And so we are going to simply option 1. There's 2 ways to think about this. Most people think about it this way. Since we're solving an equation, whatever you do to one side of the equation, you have to do to the other side of the equation. So we will apply log base 4 to both sides. Can I scroll up yet?
Yes.
Cool. Okay. Fantastic. So what we have here is we have 4 to the 2x is equal to 1/2. And we're going to take log base 4 of both sides. Now, there's a couple of different ways that this can go. In terms of your thought process, we can use log rules, log properties, which we talked about yesterday, which say that if you have log base b of x to the n power, you can bring down that power as a coefficient. Or if we have matching bases, which is exactly what we chose here, log base, oops, let me rewrite this generically. Log base b of b raised to a power, that's a cancellation law. So either way we cut this, if we want to bring down our power as a coefficient, this is 2x times log base 4 of 4 is equal to the log base 4 of 1/2. And now we can interpret what's going on with this logarithm. This is the power that turns 4 into 4, or it's another cancellation law. And this is simply 2x times 1, as log base 4 of 4 is 1. And on the right side, we have log base 4 of 1/2. And so we can solve for x by simply dividing both sides by 2. So x is 1/2 log base 4 of 1/2. Now, we should be able to simplify this if possible. This is the power that turns 4 into 1/2. So let's see, 4 to what power equals 1/2? Well, we would have to take its square root to get 2, and then we would have to take its reciprocal. If you want to solve this directly, you can rewrite both of these again as powers of 2. But what we have here is 4 to the negative 1/2 equals 1/2, as this is 1 over the square root of 4 is equal to 1/2. So again, I really hope you're up on your exponential rules that we reviewed yesterday. They're going to be really, really important in this section. And what we have here is x is equal to 1/2 times -1/2, which is -1/4. Now that was a little bit more complicated than it needed to be. Just because I'm applying all of these rules and there's easier ways to do this particular problem. But we have a second option. Option 2, and this might be the best way to go if you know what you're talking about. 4 to the 2x is equal to 1/2 is our equation. And if you followed yesterday's conversation about translation, just translate it into log form. What do I mean by that? Well, this expression is the power that turns 4 into 1/2 is 2x. That's how you can read that. Instead of saying 4 to the 2x is equal to 1/2, we can say the power that turns 4 into 1/2 is 2x, which means that this becomes the power that turns 4 into 1/2 is 2x. And so we sidestep just quite a few steps from option 1. And then we can solve for x. X is 1/2 log base 4 of 1/2, which is equal to -1/4, again, for the same reasons. So there you have it. I think the easiest way to do this particular problem, though, is with that idea of simple exponential equations, where we rewrite everything in terms of the same base, although it's more or less the same thing. However, when we get to the more advanced problems, option 2 is probably going to be the way to go here. So keep working on your translation. Let's do a more general problem. So, general exponential equations, solving them. Here's an example. 5 to the -x is equal to 2. Now, this is a more general exponential equation because 5 and 2 are different bases. So the way to go here would just be to translate. The power that turns 5 into 2 is -x. This implies that x is equal to negative log base 5 of 2. And that's your answer. If you have a calculator, you can approximate that. Again, as we talked about yesterday, your calculator, though, doesn't have a log base 5 button. So we'd have to use our change of base formula. And this would be the negative of log base 10 of 2 over log base 10 of 5. You could have also used the natural log there for your calculator, but that'll work for us. If we go to our calculator here, this is, where's my log button? Log 2 divided by log 5. And that's about 0.43. So this will be approximately negative 0.43 is our value. And we had to really use the calculator there simply because 5 and 2 were different bases. So unless you want a general expression here, this 5 and this 2 aren't going to have anything in common that are going to allow us to simplify that by hand or analytically, as it were. Okay. Stop me if you got any questions. Okay. Example 3. This one is more or less the same problem with a little bit of algebra slapped on the front. Let's see here. Solve for t. They're changing the variable up on us. 5,000 divided by 1 plus 2e. Helena, your microphone's on and we can hear some background chatter. Thank you.
My bad.
You're cool. It's cool, man. It happens. The other day in one of my classes, it was a yapping dog for a little while, and then somebody yelling at that dog constantly.
My cat's running around my keyboard. I think she turned it on.
For sure. For sure. Okay. So I'll edit that out with the magic of post-production. Let me start over here. Example number 3 for solving exponential equations is a pretty straightforward example. The only real difference between this and the last couple of examples is the fact that there is some algebra thrown at us in the beginning. So what you want to do here in a situation like this is identify the exponential term or factor in your expression. And what you want to do is you want to treat that like your variable at first. What you want to do here is you want to isolate your exponential. So begin by isolating the exponential, in this case, e to the negative 3t. As we can see in our last example, this was the exponential, and it was already isolated, as was in our first example. The exponential was already by itself on one side of the equation, so there wasn't any extra algebra we had to do. So here, what we have is we're going to multiply both sides by the denominator. This is 5,000 is equal to 2,500 times the quantity, 1 plus 2e to the negative 3t. We'll divide both sides by 2,500. We'll get 5,000 over 2,500 is equal to 1 plus 2e to the negative 3t. This will simplify to be 2 is equal to 1 plus 2e to the 3t. We'll subtract 1 from both sides, and we'll get 1 is equal to 2e to the negative 3t. And then finally, 1/2 is equal to e to the negative 3t. And so we have isolated e to the negative 3t. Our next order of business here is to translate or take the appropriate log of both sides. So some people like that better. If you are uncomfortable with your basic translation, we're just going to take the natural log of both sides here. So just to give you guys some flavor. Come where the flavor is, man. Here, if we translate, this is the power that turns e into 1/2 is negative 3t, or the natural log of 1/2 is equal to negative 3t. Over here, if we take the natural log of both sides, we get the natural log of 1/2 is equal to the natural log of e to the negative 3t, which is log base e of e to the negative 3t, and we get some cancellation here because these bases are the same. This is just equal to negative 3t, or the natural log of 1/2 is equal to negative 3t, and you can see here that we get the same result either way. Okay, so now it's simply a matter of solving for t. This means that t is equal to negative 1/3 the natural log of 1/2, which is approximately negative 1/3 times negative 0.6931. I don't know. Let's see. Natural log of 0.5, man. Negative 6931. What did I say? Yeah, nailed it. Divided by negative 3. It's about 2.31. Sorry, 0.231. 0-ish. And that's our value of x.